Hello friends. Today I am going to discuss about the lean manufacturing. Today we are going to discuss in detail about the seven ways. We in last lecture we discussed about the different principles of lean. The principles are Muda, Mura and Muri. Out of that, the most important is the Muda. Now the Muda talks about identifying the wastes that are in manufacturing. As we discussed earlier that 85% of the money that is being spent on any production system, it is a waste. Now, how to minimize this waste? So this money is being spent on the activities which are adding zero value to the product. Now, the lean manufacturing gives us a very precise framework to identify, classify, and eliminate this waste. It is called as the seven wastes, or in Japanese we call it as seven muda. And to make them easy to remember, we are going to use the acronym that is STEAM wood. It is for identifying the eliminating waste in the manufacturing. What basically a T mood stands for? T stands for transportation, wherein it is about any unnecessary movement of the materials or work in process inventory or the products. I stands for inventory, wherein we have an excess raw materials that are being placed, work in process, finished good beyond immediate need. So that is your inventory waste. Next one we have is the motion, where unnecessary movement of the people reaching, walking, searching. This is an unnecessary movement of people. W stands for waiting, idle time when people or machines are waiting for the next step or next product to come. The first O stands for overproduction, producing more than what the customer needs or earlier than needed. Taichi Ono has called this as the worst waste because it generates all the others. Then next O stands for overprocessing. It talks about doing more work than the customer requires. Extra steps, tighter tolerance. So these are few of the extra overprocessing things. Then the last D stands for the defects, products that do not meet the specification requiring rework, scrapping, or customer returns. Keep this slide in mind as we go through each waste, and as I describe each one, I want you to think about where you see it in processes you know. Let us move ahead one by one. So first we are going to discuss about the transportation. Now, transportation is a very important phenomenon when we talk about any large manufacturing industry. And transportation waste is an any unnecessary movement of material, parts, or finished products between location. And notice, I said unnecessary. Some transportation is unavoidable, but most of it is a symptom of poor facility design. Examples: a machine component being forklift trucked across a large factory to the next operation, documents being physically carried between building for signatures, parts being moved in and out of central warehouse when they could directly go to the next workstation. Here is the key insight. Transportation does not transform the product. The product is exactly the same before and after being transported. It adds zero value. And every time product is handled, it risks being damaged. So transportation also creates a quality risk. The root causes usually for the transportation wastes are poor plant layout, machines grouped by type rather than the by product flow, and batch production that requires centralized storage between operation. The countermeasures are powerful, which you can apply for. The first one is the cellular manufacturing that co- co-locates related operations, point of use storage that puts materials exactly where they are needed, and flow-based layouts. Usually what being done is a practically, we need to put a plant layout on a paper, draw line tracing the path of the component from start to finish. The resulting maze of crossing lines is your transportation waste, wherein you can identify the visible and measurable. This is usually done by a spaghetti diagram. Next, so the first one that we discussed about transportation, the second waste is about inventory. And this one is very tricky because conventional manufacturing wisdom says that inventory is a good thing, safety stock, buffer stock, just in case stock. Lean says inventory is enemy. Taiichi Ohno had a powerful metaphor. He compared a factory to an ocean. The water level is the inventory. Below the surface are rocks, which we can uh, say as a problems like machine breakdowns, supplier unreliability, quality defects, and poor planning. When inventory is high, it covers all the rocks. Everything seems fine, but the problems are still there, hidden, getting worse. When you lower the inventory, the water level drops, and suddenly the rocks appear. Breakdowns become visible. Supplier issues surface. Quality problems can no longer hide, and now you can actually solve them. What are the different types of inventory waste that we can have? Is usually an excess raw material that ties up cash, work in progress inventory piling up between station, and finished goods sitting in the warehouse waiting for the customers that may not come. So these are the different inventories that can be very dangerous for an industry. So as a lean, it says it is an enemy for the industry. Now, what could be the root causes for this kind of inventory? The first root cause can be a push production based on forecast, the large batch sizes, long changeover times, unreliable suppliers. So they all account for the inventory. Again, the poor demand forecasting. If your marketing team is not doing proper survey, then you are the culprit of the poor demand forecasting, which will again increase your inventory. Now, what are the countermeasures to avoid the inventory? First one, we need to go for a pull system, then go for Kanban. What is this Kanban? We'll see in the subsequent slides. Then reduce changeover times, usually known as a single minute die exchange die, SMED. This is a very popular term in the industry, wherein we need to reduce the changeover times. As the name suggesting, we have to keep it within a minute. Then the supplier development, we have to go for a vendor development. We have to trust, we have to develop a vendor where the vendors are very reliable. They can provide us the raw material as and when required. So these are few countermeasures that we can have to avoid the inventory waste. Now the as the OEO's famous quote says that inventory is the root of all evil in manufacturing. It hides every other problems. The rocks in the ocean metaphor is one of the lean's most powerful teaching tool. So you need to spend much time on the inventory. Inventory is a very important kind of waste you need to focus on. Moving ahead, the third waste we have is the motion. Now this motion talks about unnecessary movement of people. The first thing that we discussed is about movement of the goods, that is transportation. Now the third waste talks about the motion. Motion is different from transportation. So transportation is moving materials. Motion is about moving people. Motion waste is in any unnecessary movement of operators that does not add value to the product. For example, reaching across a bench for a tool, walking to a storage area which is 20 meters away to collect the things, components, bending down repeatedly to pick up the objects. This sounds very small, but again, when we consider in a bulk thing, you can identify what things it can happen. For example, let us say an operator walks 200 meters more than the necessary per part, and now you are producing 400 parts per day. Now, if you multiply 400 multiplied by 200 meters, the amount that is being piled up is around 80 kilometers of wasted walking per day, and that happens every day. Now, this 80 kilometers of walking is being wasted, and this is again adding up human cost too. The people will get frustrated when they every time they have to walk for 200 meters to pick up something. They will have some fatigue, injury risk, there is a time loss, then the reduced productivity. So these are the few impacts that can happen by designing a different motion, or motion waste is more. Usually the root causes for this are poorly designed workstations. So workstation need to be organized by keeping in mind ergonomics. Ergonomics is a very important part when we are designing a workstation. When we organize the tool storage, where can person can reach, put on a standard work layout, then multiple storage location for the same item. People are finding it difficult to pick up the same part. Like one part is kept in, there are two bins, 2 to 3 bins, wherein the same parts have been kept in that 3 bins. Now people are finding it difficult from which bin they have to pick up the objects. So these are the few of the root causes. Now what could be the countermeasures for this? The countermeasures are 5S workplace organization. So what is this 5S? We'll discuss in the upcoming slide. Now this 5S is about talking about the different movements that we have, keeping it clean, how to organize the workstations. So it talks about the organization behaviors. So that we'll discuss in the upcoming slides. Then the ergonomic workstation design, as we discussed earlier. Then put a point of use storage, keep a standardized work layouts which are visible, and everything then that an operator needs should be within the arm's reach. No searching, no walking, no stretching. We have to do the motion study before analyzing the work layouts. So keep everything nearby so that the operator also won't be getting a fatigue, and we will have the required productions levels being done. Next is the waste for, that is wetting. Now this is a very disastrous wetting, and is the biggest waste in terms of total elapsed time. Though it is a pervasive, the least dramatic looking, but wetting waste occurs when people, machines, or materials are idle, waiting for next step. So that is a very um, dangerous thing in any production industry, because it will add up your work in process inventory if the parts are waiting. Now here in this case, nobody is doing anything wrong. The machine is working, the parts are sitting there, but nothing is happening. Now, what are the different types of waiting we have? The first one we have is the machine waiting. A machine waits for a material because the previous process ran out, or the delivery was late. An operator waits for a machine that is still running. A batch of parts waits in a queue to be processed next. A product waits for an approval, a signature, or an inspection. So these are all different types of waiting. Now take any product in your factory and track it from when the order is being placed and to when it ships. Record total elapsed time, then record the time product was actually being worked on. In most factories, the ratio is shocking. Product spends 95% of its time waiting. Now, this is what I said earlier, that is, it's a kind of a disastrous waste. If 95% of the time, if the product is waiting, that means it's killing your time. As we already discussed, that tag time is very important when we talk about a lean manufacturing, right? Now, what could be the root cause? The root causes are unbalanced workloads between station, machine breakdowns, long setup time, supply chain delays, poor scheduling. Now the countermeasures that you can take to avoid this waste: line balancing to the takt time, go for a predictive maintenance, SMED for faster setups, cross training operators. Now the critical fact is that waiting is accepted as normal until you calculate its cost. Then it becomes unacceptable. Now, usually, if you walk through the shop floor, you'll identify the part is waiting. You think that the operations are going on, the worker is doing work, but when you actually calculate the times, as we discussed earlier, you have to calculate from when it enters in the shop floor and when it goes out of the shop floor. Now, there you'll actually identify what is happening. If you take just general walk, then you'll identify the workers are working, machines are working. Superficially, it feels that everything is going on fine. But in actual case, when you actually count the values, then you'll identify that is a very disastrous waste. Then the fifth number of waste is overproduction. Now this is called as a worst waste. The first one, earlier one, we called it as a disastrous. Then this is a worst waste. Now what this overproduction means? So it means producing more than what the customer needs or producing it earlier than it is needed. The Taichi owner has said that this is a worst way. Why? Because overproduction is the master waste. It generates all the other waste. When you produce more than the customer needs or earlier than they need, you create an inventory. That inventory requires transportation to storage. It occupies floor space, causes motion waste, it hides defects, it consumes machine capacity that could have produced something valuable. Overproduction looks productive. Machines are running, operators are busy, output members are high, but the product is being made is not needed yet or possibly ever. It is a waste of wearing the costume of productivity. For example, a machine operator produces a full batch of 500 parts because the setup cost is high. Even though only 100 are needed for this week, a factory produces to forecast in January for orders that may come in June, tying up a cache or floor space for months. So if you are producing a 500 components, the 400 components will be waiting till June. So 6 months you'll be holding a 400 components, and during 6 months anything can happen. The product might have some corrosion that is being happening. Then you need to do some rework. So these kind of things can happen when we go for an overproduction. Usually we need to avoid overproduction. It is to be done as and when needed. Sometimes the demands are very high. Now, in that case, we can go for an overproduction. But again, we have to be very sure about it. The the demand, we have to be very sure about the demand, and then only you have to provide. Now, the root cause for this is the perverse incentive of measuring machine utilization rather than the customer value delivery. Now, usually in the production shop floor, people talks about the OEE, that is overall equipment efficiency, or they want to improve the productivity of the system. But this productivity need to be improved as and when it is required by the customer. If the customer is not asking for your productivity, then you should not be going for. So because the lean talks about a customer centric focus. Now, what can be the countermeasures? So you can usually go for pull production or JIT, just in time. You reduce the lot sizes, do the production leveling with Heijunka, tag time alignment, reduce lot sizes. So these are all things that we can do. Now the key insight is that machine running at 100 capacity is not a goal if it produces unwanted inventory. That is the statement to be remembered. The next part of waste is over processing. Now when we talk about an over processing, Now, this is the sneakiest West because it often masquerades as a quality or diligence. Overprocessing means doing more work on a product than the customer actually requires, applying tighter tolerances than the design specifies, using a precision CNC machine for a job that simple operation could do, polishing a surface that will be hidden inside an assembly, producing a beautifully formatted 50-page report that the recipient reads for a 30 seconds. So that is all a kind of an overprocessing. Engineers are particularly prone to overprocessing. We always love to over engineer. We specify tolerances to the 4 decimal places just to be safe. We add features that nobody requested. We run materials through extra cleaning steps that the customer never asks for. So this is a very important aspect. We need to think about the customer's perspective. So the voice of customer need to be heard, and accordingly we need to produce the quality. So quality product, we no doubt we have to provide a good quality material, but again we have to think about what the customer is asking for. Is the customer is asking for Six Sigma quality, or if he's satisfied with the 5 Sigma, yes, then why to go for 6 Sigma if the customer is happy for 5 Sigma as well. So this is again a debatable question, but again, as in lean, we talk about it should be a customer focus. So when we talk about a customer focus, produce as and when it is needed, and produce as per the customer demands, not what you think about. Okay? Now, the countermeasures that we can do for it is voice of customer need to be analyzed. So do the proper voice of customer analysis, VOC analysis, uh, clear process standards, go for design for manufacturability. Now, is this a step for a customer or for us? Let me know in the comments. Okay. Now, if it's for internal comfort, it may be a waste. Okay. Now, the mistake proofing can be done once, better than repeated inspection. So the Pokayoki is the concept that need to be implemented when we are designing a process. Okay. Now, moving ahead, the next kind of a waste is a defects. The waste number 7, that is defects. Products that do not conform to specification requiring rework, scrapping, or worse, reaching the customer and triggering the returns and warranty claims. So this is a worst kind of an uh, invest. You must have heard about many companies are calling up the vehicles that they have missed some kind of a sensor alignment or any kind of brake alignments and all. So this is a very what you can say, very dangerous to any industry. So this reduces your value in the market. So we need to avoid the defects. So defects need to be avoided. If any defects have been identified during production, yes, then the countermeasures to be taken so that the defects are not being again repeated. Okay. Now defects are visible and measurable, and this is why many organizations focus on them first. But from lean perspective, defects are a symptom. The root cause lies in unstable process. So defect is finally is an outcome of what are the processes that you have done in your manufacturing industry. Now there is a critical economic principle about defects. The cost multiplies by a factor of 10 at each stage. A defect caught at the operation cost may require 1 rupee to fix. The same defect caught at the final inspection will cost 10 rupees. Then if it is caught at the customer end, it will cost 100 rupees or more in warranty, logistic, reputation damage, loss of future business. So these are all some what you can say the outcomes of the defects. Okay. Now, what are the different types of defects that we can have? Is the internal failure caught before shipment, expensive but magnifiable. External failures reaching the customer, potentially it's a catastrophic to the industry. Now, what could be the root causes? The root causes can be a process instability, lack of standard work, insufficient training, complex assemblies with high error potential. Now, the countermeasures that you can take is you can use a Pokayoke, that is error proofing. For example, how you can do a Pokayoke is that we want to ensure the alignments of the product when they are being assembled. Now, what you can do is we can design a kind of a systems wherein in one side we can put a tapered nut bolt, tapered a nut, and one side we put a normal nuts. Okay. Now, if the tapered section goes in the normal kind of section, then it won't be an assembly. So this is a kind of an error proofing that can be done. That is a very simple example I talk about, but there can be multiple things that can be done to avoid the errors. Okay. Then the Jidoka, that is will be looking for an um, automation wherein the machine that detects abnormalities and stop automatically. Then put a statistical process control measures to monitor the control and process variation, standardize work to ensure every operation is performed correctly every time. The ultimate goal is to reach for a zero defects, not through inspection but through designing the process where defects are physically impossible. The rule of thumb that you have to remember that the cost of defect rises 10 times at each stage from operation, assembly, test to the customer. Now, if it is identified at the customer end, then it's a very catastrophic for your company's reputation. So we need to be very much assured about the defects. You have to design the process in such a way that the defects are being identified either in the operation or assembly stage itself, even not to be identified in test stage. So these are all seven defects. Now, there is one more defect that is being identified as the eighth waste. Now, that is the unused human talent. Now, this is not included in the original lean definition, but again, this is again a very important kind of waste, and it is a very most important. The unused human talent is the waste of not engaging or involving or utilizing the full knowledge, creativity, and problem solving ability of your workforce. This waste was not in the Taiichi Ohno's original list because at Toyota, worker involvement was always assumed. But when lean spread to the Western organization, observe noticed that even companies implementing lean tools brilliantly often ignored their most valuable asset, the people doing the work. For example, an assembly operator notices a recurring quality issue but has no channel to report it. A maintenance technician has an idea to prevent a recurring breakdown but is never asked. Nobody asked him what can be done to avoid this. An experienced line worker knows a faster method but no one asks for their input. So these are all a few examples that can be uh, considered as a waste. Toyota receives over a million improvement ideas per year from its workforce. Most Western companies receive almost none because the systems and culture to capture them do not exist. So that is what happening in most of the industries. So we need to listen to the workers as well. So the worker might have some idea. Even though he's a worker, we need not to criticize him. We need to understand because he's daily doing that kind of work. So he has some expertise achieved over us because as a manager, as a manager, we are working on the things in the what you can say bird eyes view. Okay, so we are looking at the things in the bird eye perspective, but the worker is looking at only one particular thing, and he might be having a more knowledge about that particular thing. So we need to listen to them as well. Now, this is a very important waste that we need to identify and we need to work on as well. So this will again add up value to the industry. The people will feel that they are being asked for something which they are doing, and they'll feel connected with the industry. So this is again some what you can say the human behavior skills that are being achieved. So that is also a very important thing. Now, this is the last step in a lean. What we can do is identifying waste. What can be a practical framework for this? Now, we have understood all these seven and plus eight ways, but how do we actually go and find them in the real world? The most important step is a Gemba walk. What is a Gemba walk? Now, you have to go and see. What you have to go and see? You have to go and see the actual production. Walk on the production floor, the actual workplace where the value is created. Put on your safety shoes, go to the floor, observe not from the mezzanine, not from the control room, walk the actual process. Don't rely on the reports or assumptions that are being submitted to you, because usually the supervisors are going to provide you the reports that sometimes the reports are may be generated as a fake to give you uh, overview like all things are going in fine, but and in actual case it might not be. So you need to be very much assured. You need to take a Gemba walk and find out your own mistakes that is happening. So during a Gemba walk, you do your four things. Observe silently without interfering. Ask questions of operators, not their supervisors. Take notes and photos and resist the urge to jump to solution. Do not come to completely conclusion directly. Take out the process observations, observe each step. Is it a pure waste? Find out everything. Make a spaghetti diagram. Map the movement of people or materials on the floor plan. So find out the diagram. Every time something moves from one location to another, you draw a line. The resulting tangle of lines will reveal that transportation and motion waste visually and powerfully. Now the record operation and analyze frame by frame. Video analysis. That is again a very incredibly powerful record and operation. Watch it back at half speed. Motion waste that seems invisible in real time becomes obvious on the video. And the most important, value stream mapping, the comprehensive tool that maps entire workflow and calculates the value added ratio. Now remember the five whys. When you find a waste, do not just describe it. Ask why it exists, then ask why that is true, and keep it ask until you reach the root cause. Usually go for 4 or 5 levels deep. Now, this is all about uh, lean manufacturing principles, the identifying waste. So we, to conclude, we are understood about the T mood. T mood stands for the first one is transportation. I stands for inventory. M stands for M stands for motion. Then we have um, W stands for waiting. O stands for overproduction. Next O stands for overprocessing. D stands for defects. And the eighth one, that is a unused human talent. So these are all different ways that are being